Okay. Okay, beautiful. You will need a calculator for this, so if you need to borrow one, feel free to come grab one. So let's just kind of get the note stuff over with, and then we'll have a little bit of time at the end to practice. So yesterday we were talking about converting back and forth. So we are familiar with degrees, but radians is kind of this new measurement that we're going to be talking about. So we want to be able to go back and forth between them. I think this is, it doesn't really matter what order they're in, but from yesterday, you should have this written down, but I'll just make a note to myself. Anytime we're going from radians to degrees, I'm going to multiply by 180 over pi. So anytime you start with a radian and you need to go to degrees, you're multiplying by that same fraction. So I would start with 2 pi over 5. I'm going to multiply by 180 over pi. What happens is the pi's cancel, so that's delightful. I just have to do a little bit of work. I just grab my calculator because I'm lazy and it's before 8 a.m. 2 times 180 are in my numerators. That gives me 360. In the denominator, I'm just left with 5. And if I divide that out, that will give me 72 degrees. Just make sure a degree symbol is with your answer. So that's the big thing there. I kind of like those. They're not too terrible. You just kind of need to know that fraction. For us, you guys can basically always use notes or just have written down what the fraction is and you should be fine. And then the nice part is when we're going in the opposite direction, we start with degrees, we're going to radians. It's very similar. The only difference is this time we're going to multiply by, and we're going to flip that fraction, so we multiply by pi over 180. So that's the difference in the problems. So just have written down somewhere which is which. So if I start with a degree, I'm going to multiply by pi over 180. And once again, I should technically put degree symbols with the 180 just to be a little bit more exact. Because what happens is the degrees cancel. I end up with 140 pi over 180. And then I'm going to reduce this. So we said our calculator will do that for us. I'm going to grab mine because I'm feeling like I don't want to do work in my head. And that would reduce to 7 over 9. And then just remember to put that pi with your answer. So remember, when you're using a calculator, usually you don't put the pi symbol in. Because it makes it a decimal and it makes it all sorts of messy. So that is the stuff we did yesterday. So we kind of eased into it. I'm attempting to find the worksheet from today, which, way too many things saved here. So give me 1 second. Chapter 3. Hello, good morning. I really have no clue where I saved this. So this is a semi-issue. There it is. Okay. Are there any questions on that warm-up? Okay. So this is a new chapter, so I know a few people weren't here yesterday. So that's basically what we did yesterday for the new chapter stuff. So if nothing else, you write it down, and we'll continue to see that stuff in a few. Losing my mind. So I just want to write down who is here and who is not while my little thing comes up. We got Corey, we got Natalie, Darren, no Christine, Damani, no Danny, Bridget. Okay, so our main goal is just to kind of try a few things today from that little worksheet. We're not going to do the whole thing, so we'll ease ourselves in here, and that will be it. So tomorrow we have our full remote day, so I'll just see you for 20 minutes in the morning. I'm gonna be honest, I still have to plan what we're doing. I don't know what we're doing yet. So we'll do something, and then you'll have a little assignment in the afternoon. And then on Thursday, Friday will just be some practice with radian stuff. So if nothing else, you just write it down now, and you can refer to it later. So we're just gonna go with it. And that's it. So number 1 says for the angle 11 pi over 9. When I say that angle, like even I'm a math teacher and I can't even really visualize where that is. So it's asking us to sketch it. So remember when we sketch, we just go to our quadrants and think about where it is. And I have no clue where it is. So anytime you see a radian and you're like, I can't really visualize it, I don't know what's happening, always just convert it to a degree, because we can visualize degrees. Once again, I have no clue what quadrant it's in, I'm just like, I'm going in blind here. So if you ever have just a random radian, you can always convert it, just to make it easier to think about. So if I think of 11 pi over 9, if I want to convert this to a degree, I'm going to multiply by 180 over pi. All right, it's under 80 degrees. So it's always that same fraction, so just make sure if you write it somewhere, that will be helpful. What's happening here is the pi's are going to cancel. We're just going to kind of multiply over. I'm going to grab my calculator to do so. So we have 11 times 180. I don't know what that is, 1980. There we go. Over 9, because 9 was all that was up to the bottom. And then I'm just going to divide that out. 220 degrees. There you go. So I would have never known that had I not converted it. I would have just been kind of guessing where it was. So if I asked you to sketch this, we sketch from our initial side. We kind of go up, we go counterclockwise. And each quadrant's 90. So 90, 180, 220 would be somewhere in here. And it asks what quadrant does it lie in. It's in the 3rd quadrant. So just as a heads up there, so we have this new unit of measuring. So once again, it's kind of like talking about inches and centimeters. You're measuring the same thing, it's just a different unit of measure. So in the United States, we're like the only people that use inches. Do you use centimeters?
Yeah.
Metric system? So like if I said something in inches, would you convert it to centimeters?
Maybe I can submit like 3 centimeters and a half.
Okay, so yeah. So you might have to convert back and forth because she uses the metric system and we don't. And when you move here, it's like, I don't know what the heck that is. So it's kind of the same thing. Like, I don't know what the heck a radian is, so I always convert it back to degrees because that's something I can actually visualize. So in B, it says find 2 coterminal angles. So for degrees, we add or subtract 360. So I'm just going to make a little note to myself. So for coterminals, so degrees, we add or subtract 360. For radians, we add or subtract 360 degrees, and radians is 2 pi. How exciting. So you can do this in 2 ways. You can either take the degree and add and subtract 360 and then convert it back, or you can just take the original radian and do it with 2 pi. I'm going to do it that way, just to kind of get used to it. So I'm going to take my original angle of 11 pi over 9, and I'm going to add 2 pi. This is not something I want to do in my head. You're more than welcome to if you want. You have to find common denominators. So I use my nice calculator here. Use those fraction buttons to your advantage. I'm going to do 11 over 9. So once again, when we're throwing things in our calculator, don't put the pi symbol. It makes it all sorts of messy and decimals and yuckiness. So I put 11 over 9 into my calculator, and then I just add 2 to it. And that's going to give me 29 over 9. Okay. And then I just make sure with my answer, I'm going to put a pi. So once again, if you weren't here yesterday, I can give people some tutorials on how to use your fractions on your calculator if you need them. But we do want answers in fractions. But when I throw it in my calculator, do not put the pi symbol. I'm just putting 11 over 9 plus 2, basically. It will give me my answer as a fraction, and then you just put your pi with the same. And now let's just say, let's subtract 2 pi, just for fun. Because we can add or subtract 2 pi, we can keep going. So once again, in my calculator, I'm just doing 11 over 9. I'm not putting the pi symbol in, and I'm going to subtract 2. Once again, no pi symbol. And that's going to give me negative 7/9. And then you just add the pi into your answer. That's something we're actually going to do a lot later. But knowing how to use your calculator, and I can help people in a minute, is going to be to your advantage. So just as a heads up there. So I'm just going to leave that for a second. I know it's the morning and we're a little tired. And I don't want to kill you. I'm just going to quickly do my remote attendance, if anyone's catching up here. Sorry. Trying to be 7 places at once here. All right. Sorry. Trying to multitask. It's not easy. Okay. So we just have one more thing we're going to do today. So once again, not trying to kill you with the amount of stuff. I'm just trying to introduce this new chapter 3. So we're going to be dealing a lot with radians. So we just want to get used to kind of going back and forth because we're kind of used to degrees at this point. Are there any questions on number 1? Okay. So we're going to talk about 2 formulas. We're only going to use one today. We'll write the other one down. The main thing with these formulas, and there's little stars there, that all angles need to be in radians to use them. So you can never plug a degree into these formulas. And that's hence why it's in the radian chapter. So I'm going, oh, hey, how are you? Good morning. Welcome to have a minute before you do the
They said I don't need a note. Is that okay?
Yeah, that's fine.
Okay.
Yeah, if it's before 7:45 and you walked in at 7:44. All right. So sorry, I'm just trying to. Oh, actually, we've used both, but that's fine. That actually makes it easier. So all we're gonna do up to number 7. So it shouldn't be too bad because most of this is going to be plugging into your calculator again, and then we'll kind of reevaluate and see where we at. So we have 2 formulas, arc length. So when we're talking about arc length, if you think about a circle, you think about kind of taking a piece of it, the arc length is this distance. So we know how to find a distance if it's a line. That would just be a triangle. But in this case, our triangle has one curved side. So that's called arc length. Our formula is S equals R theta. Okay, so that's not a bad formula. Just as a heads up, S is arc length. R is radius. And theta is your angle, but it has to be in radians. Once again, a nice quick little formula. And we'll kind of get used to it today. So we won't do anything too fancy with it, but just get used to plugging in. And then area of a sector, if you think about kind of the same idea, where you have a circle and you're thinking kind of about taking a piece of it. The area of a sector is the area of that basic piece of pie. So once again, the issue is one of the sides is curved, so we need this special formula. And it's A equals 1/2 r squared theta, where A is area, r is radius, and theta is your angle, and once again, it has to be in radians. I'll give you a second if you're writing this down. Okay. So main goal today is just get used to kind of plugging into them, and then we'll see how we feel. Sorry, I just need to move this for 1 second. I just didn't know what that problem was. Beautiful. So when it says find the arc length, I'm just going to remind myself I'm using S equals r theta for these ones. I'm just going to plug in what I know. So when I think of S equals r theta, r is 4. Okay, I can throw that in there. I always use parentheses. And theta is 3 pi over 2, which is a radian, so I'm good. Actually, don't have to do anything too fancy here. I basically just throw that in my calculator. In this case, I am going to put the pi in, so I can just get a decimal answer, which is fine. So can you use your calculator right now and try to type in 4 times 3, find your pi symbol, so throw that in your calculator because we're going to get a decimal, over 2, and it should come out to about 18.85, all around 2. And in this case, it would be inches. So see, the big thing, can you find your pi symbol in your calculator? It's mine is yours. So actually try it. So just throw in a 4 times 3, find your pi symbol. Don't put 3.14. Actually, there's a pi symbol somewhere in your calculator. It just depends what calculator you have. So 3 pi, and then divide that by 2, and then press enter. You should get 18.85, but please try it twice now. And if anyone's having calculator issues or you can't find something, just let me know and I can look at yours. Great. So number 3 is kind of the same idea, so I kind of like these because they're just quick plug-ins. The issue is when I'm thinking about S equals r theta and I want to throw theta in, this is in degrees and I need it in radians. So I just kind of go up here and I remind myself of my step. I'm going to multiply it by pi over 180. Technically, you don't even really need to reduce it. I do it out of habit. So I multiplied it by pi over 180. I'm going to reduce 40 over 180, which comes out to 2 pi over 9. So this is what I'm going to use for my theta. So if you see a degree, you have to convert it to a radian. And then you can just throw in your information. S equals, r is 12. And then theta, we converted to our radian of 2 pi over 9. And then once again, I'm just using my calculator to do that math out. So 12 times 2 pi over 9 is going to give me 8.38-ish. That would be centimeters because the original was in centimeters. But once again, they're kind of just quick plugins. It's just making sure you're plugging correctly. And then the last one, number 4. A little bit of different information here. We're given S and R, so we're just trying to find the missing variable. So if I think about S equals r theta, S is 14, R is 10. I want to find what theta is, so I would just divide both sides by 10. So quick little one-step equation. And theta is going to equal 1.4. You would just write 1.4 and your answer would be in radians. Because once again, if you have to plug in the radian, that means you get out a radian. So we'll that's as crazy as we'll get today with these. Eventually we do some other types of fun problems. But we'll kind of just start by getting introduced to the formulas today. All right, we're gonna kind of do the same thing for 5, 6, 7. We're just using the other formula for area. And then we'll leave the rest of those for after. I will give you one kind of one. But why do I still not know the times of the classes? 8:16. Yes, I do. Never. So area of the sector, the formula is up there. It's A equals 1/2 r squared theta. You just need to make sure your theta is in radians. And in this case it is, so we just kind of plug it in. So it's 1/2. R is 5, so we're going to do 5 squared. And theta, once again, is in radians because there's no degree symbol, so 6 pi over 7 is beautiful. So once again, this is just going right in my calculator. I just do it in one step, so don't do anything too fancy where you're splitting it up. I just do 0.5 for 1/2, and then I do 5 squared, and then I throw in 6 pi over 7. I get into the habit, I use the parentheses kind of like I put them there, so I do the same thing in the calculator. So if you're trying to plug it in and it's not coming out to the same thing, maybe try to throw those parentheses in. When you're finding area, it's your measurement squared, so that would be meters squared. But actually practice and see if you're okay with plugging into your calculator, because before we do those like word problems, we might do a little quiz or a little assessment, just to hopefully get in another grade. Let's say the 5th, I think the term ends in the So the other ones are pretty similar. It's really just plugging into a formula, which is nice. Number 6, you do have to convert this to radians before you start. So I'm going to multiply by pi over 180. I'm just going to reduce this right in my calculator. If I do 150 over 180, that would give me 5 pi over 6. So that's what I'm going to use for my theta, and I'm just going to throw it in. 1/2, 8 squared, and then I'm using 5 pi over 6 because I need to use the radian measure. But once I know all that stuff, I just use my calculator. I don't know what this is going to come out to, 83.78. And that's inches, and then remember it's always squared when you're finding an area. And then last but not least, we think about our formula. We plug in what we know, so don't just assume you know or they're the same. A is 12. R is 4. I don't know theta. So I'm going to kind of figure out what the heck is this so I can get rid of it. So what's 1/2 of 4 squared? That would be 8, right? Yeah. So 12 is going to equal 8 theta. And then I would just divide both sides by 8. So I don't want you to think, anytime you find theta, if it's a radian, it doesn't necessarily need to have a pi symbol. I feel like we get into the habit of having the pi's there. That just means it's kind of simplified out for us. So we would just say 1.5 radians. So you don't necessarily always have a pi symbol when you have a radian. And that, my friends, is what we focused on today. So I'm going to leave that up for a second. We are going to do a wrap up in one moment. So don't necessarily put your stuff away yet. And I can kind of check in with people and see if people need individual help. Or if anyone has any questions. Sorry, I'm just going to